Good day everyone, I am Ninyo Jan P. Coritico. I will continue the reporting about motor branch circuit and ground fault protection under the article 4.30 motor circuits and controllers. So we have here the rating of circuit breaker. A circuit breaker for motor branch circuit, short circuit, and ground fault protection shall have a current rating in accordance with 4.30.4.2. So unsay naani katong kuani morning maximum rating or setting of motor branch circuit, short circuit, and ground fault protective device. Kung mahinumdaman to katong naay table bitaw. Then 4.30.9.10. So atong matakal pa ni ini later sa atong discussion. So next is motor feeder short circuit and ground fault protection. So first is 4.30.5.1 general. So part 4.30.5 specify protective devices intended to protect feeder conductors supplying motors against overcurrents due to short circuits or grounds. Next is rating or setting motor load. First, specific load. A feeder supplying a specific fixed motor loads and consisting of conductor sizes based on 4.30.2.4 shall be provided with a protective device having a rating or setting not greater than the largest rating or setting of the branch circuit, short circuit, and ground fault protective device for any motor supplied by the feeder. So based on the maximum permitted value for the specific type of protective device in accordance with the 4.30.4.2 or 4.43.2a for hermetic refrigerant motor compressors. So plus the sum of the full load currents of the other motors of the group. Where the same rating or setting of the branch circuit, short circuit, and ground fault protective device is used on two or more of the branch circuits supplied by the feeder. One of the protective devices shall be considered the largest for the above calculations. So, nani exception. So, first exception is where one or more instantaneous trip circuit breakers or motor short circuit protectors are used for motor branch circuit, short circuit, and ground fault protections as permitted in 4.30.4.2 C. The procedure provided above for determining the maximum rating of the feeder protective device shall apply with the following provisions. For the purpose of the calculation, each instantaneous strip circuit breaker or motor short circuit protector shall be assumed to have a rating not exceeding the maximum percentage of motor full load current permitted by table 4.30.4.2. Malay itong table. Mahinom naman yun sa bitaw. Then, for the type of feeder protective device employed. So, the second exception is where the feeder overcurrent protective device also provides overcurrent protection for a motor control center. The provision of 4.30.8.3 shall apply. So, B. Other installations. So, where feeder conductors have an ampacity greater than required by 4.30.2.4, the rating or setting of the feeder overcurrent protective device shall be permitted to be based on the ampacity of the feeder conductors. So, next is 4.30.5.3. Atong rating or setting motor load and other loads. Where feeder supplies a motor load and other loads, the feeder protective device shall have a rating not less than that required for the sum of the other loads plus the following. First, for a single motor, the rating permitted by 4.30.4.2. So, again, balik-balik punta sa 4.30. So, ato nagkuha man. So, need na itong himduman kung unsa na sa 4.30.2, which is katong maximum rating or setting for motor branch circuit, short circuit, and ground fault protective device. Second, we have for a single hermetic refrigerant motor compressor, the rating permitted by 4.40.3.2. Third is for 2 or more motors, the rating permitted by 4.30.5.2. So, exception, na po na exception niya po sa. We have the exception. Whether the feeder overcurrent device provides the overcurrent protection for a motor control center, the provision of 4.30.8.3 shall apply. So, magkakit itong 4.3.8.3 shall apply. So, next we have 4.30.6 motor control circuits. We have the 4.30.6.1 general. Part 4.3.6 contains modifications of the general requirements and applies to the particular conditions of motor control circuits. So, we have next we have 4.30.6.2 overcurrent protection. General, a motor control circuit tap from the load side of a motor branch circuit and short circuit and ground fault protective device and functioning to control the motors connected to that branch circuit shall be protective against overcurrent in accordance with 4.30.6.2. Such a tap control circuit shall not be considered to be a branch circuit and shall be permitted to be protective by either a supplementary or branch circuit overcurrent protective device. So, a motor control circuit other than such a tap control circuit shall be protective against overcurrent in accordance with 7.25.2.3 or the notes to table 10.1.1.11a and table 10.1.1.11b as applicable. Next is conductor protection. The overcurrent protection for conductor shall be provided as specified in 4.30.6.2 B1 or B2. So, nagyan po ni exemption. So, we have the first exemption where the opening of the control circuit would create a hazard, as for example, the control circuit of a fire pump motor and the like. Conductors of a control circuit shall require only short circuit and ground fault protection and shall be permitted to be protected by the motor branch circuit, short circuit, and ground fault protective devices. So we have the second exemption. Conductors supplied by the secondary side of a single phase transformer having only a 2-wire or single voltage secondary shall be permitted to be protected by the overcurrent protection provided on the primary side of the transformer, provided this protection does not exceed the value determined by multiplying the appropriate maximum rating of the overcurrent device for the secondary conductor from table 4.30.6.2b by the secondary to primary voltage ratio. Transformer secondary conductors or other than 2-wire shall not be considered to be protected by the primary overcurrent protection. First, we have separate overcurrent protection, where the motor branch circuit, short circuit, and ground fault protective device does not provide protection in accordance with 4.30.6.2 B2. Separate overcurrent protection shall be provided. The overcurrent protection shall not exceed the values specified in column A of table 30.1 43.6.2b. Second, we have branch circuit overcurrent protective device. Conductors shall be permitted to be protected by the motor branch circuit, short circuit, and ground fault protective device, and shall require only short circuit and ground fault protection. So, mga nananglan na og kuan ko no, nahinanglan na og ground fault protective device o katong motor branch circuit, short circuit. So, where the conductors do not extend beyond the motor control equipment enclosure, the rating of the protective device shall not be exceed the value specified in column B of table 4.30.6.2b. Where the conductors extend beyond the motor control equipment's enclosure, the rating of the protective device shall not exceed the values specified in column C of table 4.30.6b. Next, we have control circuit transformer. So, where a motor control circuit transformer is provided, the transformer shall be protected in accordance with 4.30.6.2 C1, then C2, then C3, C4, or C5. So, exemption, I have exemption name. Overcurrent protection shall be omitted where the opening of the control circuit would create a hazard, as for example, the control circuit of a fire pump, motor, and the like. First, we have compliance with Article 7.25, where the transformer supplies a Class 1 power limited circuit, Class 2, or Class 3 remote control circuit, complying with the requirements of Article 7.25, protection shall comply with Article 7.25. So, next is compliance with Article 4.50. Protection shall be permitted to be provided in accordance with 4.50.1.3. Third is less than 50 volt amperes. Control circuit transformer rated less than 50 volt amperes VA and that are integral part of the motor controller and located within the motor controller enclosure shall be permitted to be protected by the primary overcurrent devices, impedance limiting means, or other inherent protective device. Fourth, we have primary less than 2 amperes, where the control circuit transformer rated primary current is less than 2 amperes. An overcurrent device rated or set at no more than 500% of the rated primary current shall be permitted in the primary circuit. Fifth, we have other means. Protection shall be permitted to be provided by other approved means. Next, we have 4.30.6.3. Protection of conductors from physical damage. Where damage to a motor control circuit would constitute a hazard, all conductors of such a remote control circuit that are outside the control device itself shall be installed in a raceway or be otherwise protected by physical damage. So, kinahanglan sa daog kuan. Ang tanang ang pagconductors ko no nay protection ko no para malikay sa kuan ba damage kay kung ma-damage ko no ang isa ka conductors mo kuan device, so nazinay kuan hazard sa para sa mga tao. So next is 4.30.6.4 electrical arrangement of control circuits. Where one conductor of the motor and control circuit is grounded, the motor control circuit shall be arranged so that a ground fault in the control circuit remote from the motor controller will first, we have not start the motor. Second, not bypass manually operated shutdown devices or automatic safety shutdown devices. So next, we have 4.30.6.5 disconnection. So general, motor control circuits shall be arranged so that they will be disconnected from all sources of supply when the disconnecting means is in the open position. The disconnecting means shall be permitted to consist of two or more separate devices, one of which disconnects the motor and the controller from the sources of power supply for the motor, and the others, the motor control circuit from its power supply. Where separate devices are used, they shall be located immediately adjacent to each other. So, naya po na exception. Exemption number 1. Where more than 12 motor control circuit conductors are required to be disconnected, the disconnecting means shall be permitted to be located other than immediate adjacent to each other where all of the following conditions are complied with. First, we have access to energized parts is limited to qualified persons in accordance with Part 4.30.1.2 of this article. B. Warning sign is permanently located on the outside of each equipment enclosure, dust or cover, permitting access to the live parts in the motor control circuits. Warning that motor control circuit disconnecting means are remotely located and specifying the location and identification of each disconnect. Where energized parts are not in an equipment enclosure as permitted by 4.30.12.2 and 4.30.12.3. An additional warning sign shall be located where visible to persons who may be working in the area of the energized parts. So, exemption number 2. The motor control circuit disconnecting means shall be permitted to be remote from the motor controller power supply. Disconnecting means where the opening of one or more motor control circuit disconnecting means is capable of resulting in potentially unsafe conditions for personal or property, and the conditions of items A and B of exception number 1 are complied with. So we have here the table. So table 4.30.6.2b, maximum rating over current protective device in amperes. So we have here the control circuit conductor size in millimeter squared. Then we have the column A, separated protective ng column A, separate protection provided. So under ano kaya aluminum or copper clad. So sunod X, protection provided by motor branch circuit protective devices. Column B, conductors with enclosure. Column C is conductors extend beyond enclosure. So we have here the in control circuit conductor size, so in millimeter squared. So 0.75 or 1. Ang copper na 7. So sa aluminum or copper clad aluminum way gibutang na sa specification na. So copper 25. Then sa aluminum yapon wala gyapon. So copper 7. Sa aluminum or copper clad aluminum wala gyapon. So ang 1.25 1.2 copper 10. Sa aluminum wala gyapon. Then sa column B 40 ang copper. Then sa column C ang copper 10. Next is 2.0 1.6. So ang copper kuno nasa note 1. Then sa column B 100. Ang column C 45. Next is 3.5, so 2. Nagyapon sa ang copper nasa note 1. So ang aluminum copper clad aluminum yapon nasa note yapon. Then ang column B 120. Sa aluminum or copper clad aluminum 100. Then sa column C 60. Then sa isang aluminum copper clad aluminum 45. Next is 5.5 2.6. Note 1 yapon ang nasa note 1 kuno ang copper. So hasta pod ang aluminum. Column B is 160. Then sa aluminum 140. Then sa column C ang copper niya is 90. Then ang aluminum or copper clad aluminum 75. So larger than 10 ang column A nasa note 1 yapon. Hasta pod ang aluminum copper clad. Then sa column B nasa ang copper o ang aluminum nasa note 2. Then sa column C ang isang copper o aluminum copper clad aluminum is nasa note 3. So next is B. control transformer and controller enclosure, where a transformer or other device is used to obtain a reduced voltage for the motor control circuit and is located in the controller enclosure. Such transformer or other device shall be connected to the load side of the disconnecting means for the motor control circuit. So we have here the motor 4.30.7 motor controllers. 4.30.7.1 General. Part 4.30.7 is intended to require suitable controllers for all motors. So, first we have stationary motor of 1.8 horsepower or less. For a stationary motor rated at 1.8 horsepower or less that is normally left running and is constructed so that it cannot be damaged by overload or failure to start, such as clock motors and the like, the branch circuit disconnecting shall be permitted to serve as controller. B. Portable motor of 1/3 horsepower or less. For a portable motor rated at 1/3 horsepower or less, the controller shall be permitted to be an attachment plug and receptacle or cord connector. So next is 4.30.7.2 controller design. First we have starting and stopping. Each controller shall be capable of starting and stopping the motor it controls and shall be capable of interrupting the lock rotor current of the motor. So B. Auto transformer. An auto transformer starter shall provide an off position, a running position, and at least one starting position. It shall be designed so that it cannot rest in the starting position or any position that will render the overload devices in the circuit inoperative. So, we have here third, C. Rheostats. Your rheostat shall be in compliance with the following. First, we have motor starting rheostats shall be designed so that the contact arm cannot be left on intermediate segments. The point or place on which the arm rests when in the starting position shall have no electrical connections with the resistor. Second, motor starting rheostats for DC motors operated from a constant voltage supply shall be equipped with automatic devices that will interrupt the supply before the speed of the motor has fallen to less than 1/3 its normal rate. Next is 4.30.7.3 ratings. So, the controller shall have a rating as specified in 4.30.7.3a, unless otherwise permitted in 4.3.7.3b or c, as specified in D. So, under the connection specified, A. General horsepower ratings. So, controllers other than inverse time circuit breakers and molded case switches shall have horsepower ratings at application voltage not lower than the horsepower rating of the motor. So, next we have second, circuit breaker. A branch circuit inverse time circuit breaker rated in ampere shall be permitted as a controller for all motors. Where this circuit breaker is also used for overload protection, it shall conform to the appropriate provisions of this article governing overload protection. So third, we have molded case switch. A molded case switch rated in ampere shall be permitted as a controller for all motors. So B. Small motors, devices as specified in 4.30.7.1a and B shall be permitted as a controller. So C. Stationary motors of 2 horsepower or less. For stationary motors rated at 2 horsepower or less and 300 volts or less, the controller shall be permitted to be either of the following. So we have here a general use switch having an ampere rating not less than twice the full load current rating of the motor. Second, an arc circuits general use switch suitable only for use and easy. natural use as AC/DC snap switches. So where the motor full load current rating is not more than 80% of the ampere rating of the switch. So D, torque motors. For torque motors, the controller shall have a continuous duty full load current rating not less than the nameplate current rating of the motor. For a motor controller rated in horsepower but not marked with the foregoing current rating, the equivalent current rating shall be determined from the horsepower rating by using table 4.30.14.1, table 4.30.14.2, table 4.30.14.3, and table 4.30.114.4. So next is voltage rating. Ang controller with a straight voltage rating, for example, 230 volts or 460 volts, shall be permitted to be applied in a circuit in which the nominal voltage between any two conductors does not exceed the controller voltage rating. A controller with a slash rating, for example, 115 over 230 volts or 460Y over 265 volts, shall only be applied in a solidly grounded circuit in which the nominal voltage to ground from any conductor does not exceed the lower of the two values of the controller's voltage rating, and the nominal voltage between any two conductors does not exceed the higher value of the controller's voltage rating. So next we have 4.30.7.4. Need not open all conductors. The controller shall not be required to open all conductors to the motor. So, nagyan po ni exemption. Where the controller serves also as a disconnecting means, it shall open all ungrounded conductors to the motor, as provided in 4.30.9.11. So next we have 4.30.7.5. In grounded conductors, one of the pole controllers shall be permitted to be placed in a permanently grounded conductors, provided the controller is designed so that the pole in the grounded conductors cannot be opened without simultaneously opening all conductors of the circuit. So next is 4.30.7.7. Number of motors served by each controller. Each motor shall be provided with an individual controller. Exemption number 1. For motors rated 1000 volts or less, a single controller rated at not less than the equivalent horsepower, as determined in accordance with 4.30.9.10 C1 of all the motors in the group shall be permitted to serve the group under any of the following conditions. First, where a number of motors drive several parts of a single machine or piece of apparatus, such as metal and woodworking machines, cranes, hoists, and similar apparatus. Second, where a group of motors is under the protection of one overcurrent device as permitted in 4.30.4.3a. Third, we have where a group of motors is located in a single room within sight from the controller location. So we have the exemption number 2. A branch circuit disconnecting means serving as the controller as allowed in 4.30.7.1a shall be permitted to serve more than one motor. Next we have 4.30.7.8. Adjustable speed motors. Adjustable speed motors that are controlled by means of field regulations shall be equipped and connected so that they cannot be started under a weakened field. So exemption, starting under a weakened field shall be permitted where the motor is designed for such starting. So 4.30.7.9 speed limitation. Machines of the following type shall be provided with speed limiting devices or other speed limiting means. First, we have spiritly excited DC motors. Second, series motors. Third, motor generators and converters that can be driven at excessive speed from the DC and as by a reversal of current or decrease in load. So, exemption. Separate speed limiting devices or means shall not be required under either of the following conditions. First, we have where the inherent characteristics of the machines, the systems or the load, and the mechanical connections thereto are such as to safely limit the speed. Second, where the machines is always under the manual control of a qualified operator. So, they operator under the qualified operator. Next, we have 4.30.7.10. Combinations for fuse holder and switch as controller. The rating of a combination fuse holder and switch used as motor controller shall be such that the fuse holder will accommodate the size of the fuse specified in Part 4.30.3 for motor overload protection. Nagya po ni exemption, where fuses having time delay appropriate for the starting characteristics of the motor are used, fuse holders of smaller size than specified in Part 4.30.3 shall be permitted. Next is 4.30.8. Ang say na ani, motor control centers. So, under sa ani, ng overcurrent protection, service equipment. So, first we have 4.30.8.1 general. Part 4.30.8 covers motor control centers installed for the control of motors, lighting, and power circuits. So, 4.30.8.3 overcurrent protection. Motor control center shall be provided with overcurrent protection in accordance with parts 2.40.1, 2.40.2, and 2.40.8. The ampere rating or setting of the overcurrent protective device shall not exceeding the rating of the common power bus. This protection shall be provided by, first, an overcurrent protective device located ahead of the motor control center. Second, a main overcurrent protective device located within the motor control center. Next, we have 4.30.8.4 service equipment. Where used as service equipment, each motor control center shall be provided with a single main disconnecting means to disconnect all ungrounded service conductors. So, exemption. A second service disconnect shall be permitted to supply additional equipment. So, where a grounded conductors is provided, the motor control center shall be provided with a main bonding jumper size in accordance with 2.50.2.9d within one of the sections for connecting the grounded conductor on its supply side to the motor control center equipment ground bus. So, naya po the exemption. Exemption is high impedance grounded neutral system shall be permitted to be connected as provided in 2.50.2.17. So, we have here 4.30.8.5 grounding. Multi-section motor control center shall be connected together with an equipment grounding conductors or equivalent equipment grounding bus size in accordance with table 2.50.6.13. So, equipment grounding conductor shall be connected to this equipment grounding bus or to a grounding termination point provided in a single section motor control center. So, we have here the 4.30.8.6 bus bars and conductors. A. Support and arrangement. Bus bars shall be protected from physical damage and be held firmly in place. So, kaya ito na ma-damage ko ang bus bars. So, other than for required interconnections and control wiring, only those conductors that are intended for terminations in a vertical section shall be located in that section. So, nagya po na exemption. Exemption niya is, conductors shall be permitted to travel horizontally through vertical sections where such conductors are isolated from the bus bars by a barrier. Next is phase arrangement. The phase arrangement on a three-phase horizontal common power and vertical buses shall be A, B, C. From front to back top to bottom or top or left to right as viewed from the front of the motor control center. The B phase shall be that phase having higher voltage to ground on 3-phase 4-wire delta connected systems other than other busbar arrangements shall be permitted for additions to existing installations and shall be marked. So exemption: rear mounted units connected to a vertical bus that is common to front mounted units shall be permitted to have a CBA phase arrangement where properly identified. So minimum wire bending space. The minimum wire bending space at the motor control center terminals and minimum gutter space shall be as required in Article 3.12d. So spacings between motor control center bus terminals and other bare metal parts shall not be less than the specified in table 4.30.8.6d. So next is barriers. Barriers shall be placed in all service entrance motor control centers to isolate service bus bars and terminals from the remainder of the motor control center. Next, we have 4.30.8.7 marking. So, motor control centers shall be marked according to 110.21 and the marking shall be plainly visible after installation. Marking shall also include common power bus current rating and motor control center short circuit rating. Next, motor control units. Motor control units in a motor control center shall comply with 4.30.1.8. So next is 4.30.8.8 available fault current. The available short circuit current at the motor control center and the date the short circuit current calculation was performed shall be documented and made available to those authorized to inspect the installation. So we have here the table 4.30.8.6d, minimum spacing between bare metal parts. So we have sa table kay nominal voltage. So iyang opposite polarity were mounted on the same surface in millimeter. Opposite polarity were held free in air in millimeter. Light bars to ground in millimeter. So not over 125 volts nominal. Ang opposite polarity were mounted on the same surface. It's 19.1. Then 12.7 sa iyang opposite polarity were held free in air. Then 12.7 niya po sa live parts to ground. Next, we have not over 250 volts nominal 31.8. Yung opposite polarity were mounted on the same surface. 19.1 sa opposite polarity were held free in air. 2.7 sa isang live parts niya po to ground. So not over 600 volts nominal 50.8. 25.4 sa opposite polarity were held free in air. 25.4 sa live parts to ground. So, we have here the 4.30.9 disconnecting mains. So, 4.30.9.1 general. Part 4.3.9 is intended to require disconnecting mains capable of disconnecting motors and controllers from the circuit. 4.30.9.2 location, controller, and individual disconnecting mains shall be provided for each controller and shall be disconnect the controller. The disconnecting mains shall be located in sight from the controller location. Ngayon po ni exemption. Exemption 1, number 1. For motor circuits over 1000 volts, nominal, a controller disconnecting means lockable in accordance with 1.10.1.25 shall be permitted to be out of sight of the controller, provided that the controller is marked with a warning label giving the location of the disconnecting means. So, exemption number 2. A single disconnecting means shall be permitted for a group of coordinated controllers that drive several parts of a single machine or piece of apparatus. The disconnecting means shall be located in sight from the controllers, and both the disconnecting means and the controller shall be located in sight from the machines or apparatus. Next is exemption number 3. The disconnecting means shall not be required to be in sight from valve, actuator, motor, assembles containing the controller where such allocation introduces additional or increased hazards to a person or property and conditions. E and B are met. So first we have the valve, actuator, motor assembly is marked with a warning label giving the locations of the disconnecting means. The disconnecting means is lockable in accordance with 1.10.1.25. So, sunod X motor. A disconnecting means shall be provided for a motor in accordance with B1 or B2. Separate motor disconnect. A disconnecting means for the motor shall be located inside from the motor location and the driven machinery location. First, we have controller disconnect. The controller disconnecting means required in accordance with 4.30.9.2a shall be permitted to serve as the disconnecting means for the motor if this is in sight from the motor location and the driven machinery location. So, nagyan pa ni exemption. Exemption to 1 and 2. The disconnecting means for the motor shall not be required under either condition A or condition B which follow, provided that the controller disconnecting means required in 4.30.9.2a is lockable in accordance with 1.10.1.25. Where such allocation of the disconnecting means for the motor is impracticable or introduces additional or increased hazards to persons or property. So next is industrial installations with written safety procedures where conditions of maintenance and supervision ensure that only qualified persons service the equipment. So next is 4.30.9.3 operation. The disconnecting means shall open all ungrounded supply conductors and shall be designed so that no pole can be operated independently. The disconnecting means shall be permitted in the same enclosure with the controller. The disconnecting means shall be designed so that it cannot be closed automatically. Next is 4.30.9.4 to be indicating. So the disconnecting means shall plainly indicate whether it is in the open or off or closed or on position. So next is 4.30.9.5 grounded conductors. One pole of the disconnecting means shall be permitted to disconnect a permanently grounded conductor, provided the disconnecting means is designed so that the pole in the grounded conductors cannot be opened without simultaneously disconnecting all conductors of the circuit. Next, we have 4.30.9.7 readily accessible. At least one of the disconnecting means shall be readily accessible. Next is 4.30.9.8. Every disconnecting means in the motor circuit between the point of attachment to the feeder or branch circuit and the point of connection to the motor shall comply with the requirements of 4.30.9.9 and 4.30.9.10. 4.30.9.9 type. The disconnecting means shall be a type specified in 4.30.9.9a unless otherwise permitted in 4.30.9.9b through G under the conditions specified. General. So first, motor circuit switch. A listed motor circuit switch rated in horsepower. Second, molded case circuit breaker. A listed molded case circuit breaker. Third, molded case switch. A listed molded case switch. Fourth, instantaneous strip circuit breaker. An instantaneous strip circuit breaker that is part of a listed combination motor controller. Fifth, we have self-protective combination controller. Listed self-protective combination controller. 6. manual motor controller. Listed manual motor controllers additionally marked suitable as motor disconnect shall be permitted as a disconnecting means were installed between the final motor branch circuit, short circuit protective device, and the motor. Listed manual motor controllers additionally marked suitable as motor disconnect shall be permitted as disconnecting means on the line side of the fuses permitted in 4.30.4.2c5. In this case, the fuses permitted in 4.3.4.2c5 shall be considered supplementary fuses, and suitable branch circuit, short circuit, and ground fault protective device shall be installed on the line side of the manual motor controller, additionally marked suitable as motor disconnect. 7. System isolation equipment. System isolation equipment shall be listed for disconnection purposes. System isolation equipment shall be installed on the load side of the overcurrent protection and its disconnecting means. The disconnecting means shall be one of the types permitted by 4.30.9.9 A1 through A3. Next is stationary motors of 1/8 horsepower or less. For stationary motors of 1/8 horsepower or less, the branch circuit overcurrent device shall be permitted to serve as the disconnecting means. C. Stationary motors of 2 horsepower or less. For stationary motors rated at 2 horsepower or less and 300 volts or less, the disconnecting means shall be permitted to be one of the devices specified in 1, 2, or 3. So, first, 1. A general use switch having an ampere rating not less than twice the full load current rating of the motor. 2. On AC circuits, a general use snap switch suitable only for use on AC. So, not general use AC/DC snap switches where the motor full load current rating is not more than 80% of the ampere rating of the switch. 3. A listed manual motor controller having a horsepower rating not less than the rating of the motor and marked suitable as motor disconnect. So, letter D. Next is letter D, auto transformer type controlled motors. For motors over 2 horsepower 2 and including 100 horsepower, the separate disconnecting means required for a motor with an auto transformer type controller shall be permitted to be general use switch where all of the following provisions are set. First, we have the motor drives as generator that is provided with overload protection. Second, the controller is capable of interrupting the locked rotor current of the motors, is provided with no voltage release, and is provided with running overload protections not exceeding 125% of the motor full load current rating. Third, we have the separate fuses or an inverse time circuit breaker rated or set not more than 150% of the motor full load current is provided in the motor branch circuit. A. Isolating switches. For stationary motors rated at more than 40 horsepower DC or 100 horsepower EC, the disconnecting means shall be permitted to be general use or isolating switch, where plainly marked do not operate under load. So F. Cord unplugged connected motors. For a cord unplugged connected motor, a horsepower rated attachment plug and receptacle, flange surface inlet and cord connector or attachment plug and cord connector having rating no less than the motor rating shall be permitted to serve as the disconnecting means. Horsepower rated attachment plugs, flange surface inlets, receptacles, and cord connector shall not be required for a cord unplugged connected appliances in accordance with 4.22.3.4. Room air conditioners in accordance with 4.40.7.4, or portable motors rated 1/3 horsepower or less. G. Torque motors. For torque motors, the disconnecting means shall be permitted to be general use switch. Next, we have 4.30.9.10, ampere rating and interrupting capacity. So, general, the disconnecting means for motor circuits rated 1000 volts nominal or less shall have an ampere rating not less than 115% of the full load current rating of the motor. Now, you have an exemption. The exemption is a listed unfused motor circuit switch having a horsepower rating not less than the motor horsepower shall be permitted to have an ampere rating less than 115% of the full load current rating of the motor. B. For torque motors, disconnecting means for a torque motor shall have an ampere rating of at least 115% of the motor nameplate current. Next is for combination loads, where two or more motors are used together or where one or more motors are used in combination with other loads, such as resistance, heaters, and where the combined load may be simultaneous on a single disconnecting means. The ampere and horsepower ratings of the combined load shall be determined as follows. So first, we have horsepower rating. The rating of the disconnecting means shall be determined from the sum of all currents, including resistance loads at the full load condition and also at the lock rotor condition. The combination of full load current and the combination lock rotor current so obtained shall be considered as a single motor for the purpose of these requirements as follows. The full load current equivalent to the horsepower rating of each motor shall be selected from Table 4.30.14.1, Table 4.30.14.2, Table 4.30.14.3, and Table 4.30.14.4. This full load current shall be added to the rating in amperes of other loads to obtain an equivalent full load current for the combined load. The lock rotor current equivalent to the horsepower rating of each motor shall be selected from Table 4.30.14.5a or Table 4.30.14.5b. The lock rotor current shall be added to the rating in amperes of other loads to obtain an equivalent lock rotor current for the combined load. So, where two or more motors or other loads cannot be started simultaneously. The largest sum of lock rotor currents of a motor or group of motors that can be started simultaneously and the full load currents of other concurrent loads shall be permitted to be used to determine the equivalent lock rotor current for the simultaneous combined loads in case where different current ratings are obtained when applying these tables. The largest value obtained shall be used. So, exemption. So, naya po na exemption. Exemption, where part of the concurrent load is resistance load, and where the disconnecting means is a switch rated in horsepower and amperes, the switch used shall be permitted to have a horsepower rating that is not less than the combined load of the motors. If the ampere rating of the switch is not less than the lock rotor current of the motor plus the resistance load. Second, we have ampere rating. The ampere rating of the disconnecting means shall not less than 115% of the sum of all currents at the full load conditions determined in accordance with 4.30.9.10 C1. So, nagya po na exemption. Isang section is a listed non-fused motor circuit switch having a horsepower rating equal to or greater than the equivalent horsepower of the combined loads determined in accordance with 4.30.9.10 C1 shall be permitted to have an ampere rating less than 115% of the sum of all currents at the full load condition. 3. Small motors. For small motors not covered by Table 4.30.14.1, Table 4.30.14.2, Table 4.30.14.3, and Table 4.30.14.4, the lock rotor current shall be assumed to be 6 times the full load current. Next, we have 4.30.9.11, switch or circuit breaker as both controller and disconnecting means. A switch or circuit breaker shall be permitted to be used as both the controller and disconnecting means if it complies with 4.30.9.11a and is one of the types specified in 4.30.9.11b. So, general. The switch or circuit breaker complies with the requirements for controllers specified in 4.30.7.3, opens all ungrounded conductors to the motor, and is protected by an overcurrent device in each ungrounded conductor, so which shall be permitted to be the branch circuit fuses. The overcurrent device protecting the controller shall be permitted to be part of the controller assembly or shall be permitted to be separate. An auto-transformer type controller shall be provided with a separate disconnecting means. So B. Type. The device shall be one of the types specified in 4.30.9.11b, 1 or B2 or B3. First, air brake switch. An air brake switch operable directly by applying the hand to a lever or a handle. Second, we have inverse time circuit breaker. An inverse time circuit breaker operable directly by applying the hand to a lever or handle. The circuit breaker shall be permitted to be both power and manually operable. Oil switch. An oil switch used on a circuit whose rating does not exceed 1000 volts or 100 amperes. The oil switch shall be permitted to be both power and manually operable. So next you have 4.30.9.12 motors served by single disconnecting means. Each motor shall be provided with an individual disconnecting means. So nagyan mo exemption. Exemption. A single disconnecting means shall be permitted to serve a group of motors under any of the following conditions of A, B, and C. The single disconnecting means shall be created in accordance with 4.30.9.10c. So, A, where a number of motors drive several parts of a single machine or piece of apparatus such as metal and woodworking machines, cranes, and hoists. B, where a group of motors is under the protection of one set of branch circuit protective device as permitted by 4.30.4.3a. C, where a group of motors is in a single room within sight from the collection of the disconnecting means. So next we have 4.30.9.13. Energy from more than one source. Motor and motor-operated equipment receiving electric energy from more than one source shall be provided with disconnecting means from each source of electric energy immediately adjacent to the equipment served. Each source shall be permitted to have separate disconnecting means where multiple disconnecting means are provided. A permanent warning shall be provided on or adjacent to each disconnecting means. So, ngayon po na exemption. Exemption number 1, where a motor receives electric energy from more than one source. The disconnecting means for the main power supply to the motor shall not be required to be immediately adjacent to the motors, provided that the controller disconnecting means is lockable in accordance with 1.10.1.25. So, exemption number 2. A separate disconnecting means shall not be required for a Class 2 remote control circuit conforming with Article 7.25, rated not more than 30 volts and isolated and ungrounded. Next, we have 4.30.10. Adjustable speed drive system. 4.30.10.1 General. The installation provisions of Part 4.30.1 through Part 4.30.9 are applicable unless modified or supplemented by Part 4.30.10. So, 4.30.10.3 Conductors, minimum size and ampacity. So, A. Branch feeder circuit conductors. Circuit conductors supplying power conversion equipment included as part of an adjustable speed drive system shall have an ampacity not less than 105% of rated input current to the power conversion equipment. Next is bypass device. For an adjustable speed drive system that utilizes a bypass device, the conductor ampacity shall not be less than required by 4.30.1.6. The ampacity of circuit conductors supplying power conversion equipment included as part of an adjustable speed drive system that utilizes a bypass device shall be the larger or either of the following. First, 125% of the rated input current to the power conversion equipment. Second, 125% of the motor full load current rating as determined by 4.30.1.6. Next, we have 4.30.10.5. Overload protection. Overload protection of the motor shall be provided. A. Included in power conversion equipment. So, where the power conversion equipment is marked to indicate that motor overload protection is included. Additional overload protection shall not be required. So, second, bypass circuits. B. For adjustable speed drive system that utilize a bypass device to allow motor operation at rated full load speed, motor overload protection as described in part 4.30.3 shall be provided in the bypass circuit. Next, C. Multiple motor application. For multiple motor application, individual motor overload protection shall be provided in accordance with part 4.30.3. So, next is 4.30.10.7. Motor over temperature protection. So, layo tayo motor over temperature protection para malikay o ma-overheat. General, adjustable speed drive system shall protect against motor over temperature condition where the motor is not rated to operate at the nameplate rated current over the speed range required by the application. This protection shall be provided in addition to the conductor protection required in 4.30.3.2. Protection shall be provided by one of the following means. First, we have motor thermal protector in accordance with 4.30.3.2. Second, adjustable speed drive system with load and speed sensitive overload protection and thermal memory retention upon shutdown or powerless. Exemption to 2. Thermal memory retention upon shutdown or power loss is not required for continuous duty loads. First, overprotection protection relay utilizing thermal sensors embedded in the motor and meeting the requirements of 4.30.3.2 A2 or B2. Second, thermal sensor embedded in the motor whose communication are received and acted upon by an adjustable speed drive system. So B, multiple motor applications. For example, for multiple motor applications, individual motor over temperature protection shall be provided as required in 4.30.10.7a. C. Automatic restarting and orderly shutdown. The provision of 4.30.3.13 and 4.30.3.14 shall apply to the motor over temperature protection means. So next we have 4.30.10.9 disconnecting means. The disconnecting means shall be permitted to be in the incoming line to the conversion equipment and shall have a rating not less than 115% of the rated input current of the conversion unit. Next, we have 4.30.10.10 branch circuit, short circuit, and ground fault protection for single motor circuits containing power conversion equipment. So, first, we have circuits containing power conversion equipment. Circuits containing power conversion equipment shall be protected by a branch circuit, short circuit, and ground fault protective device in accordance with the following. First, we have the rating and type of protection shall be determined by 4.30.4.2, C1, C3, C5, or C6 using the full load current rating of the motor load is determined by 4.30.1.6, where maximum branch circuit, short circuit, and ground fault protective ratings are stipulated for specific device types in the manufacturer's instructions for the power conversion equipment or are otherwise marked on the equipment, they shall not be exceeded even if the higher values are permitted by 4.30.10.10a1. So, next is a self-protected combination controller shall only permitted where specifically identified in the manufacturer's instructions for the power conversions equipment or if otherwise marked on the equipment. First, we have where an instantaneous strip circuit breaker or semiconductor fuses are permitted in accordance with the drive manufacturer's instruction for use as the branch circuit, short circuit, and ground fault protective device for listed power conversion equipment, these shall be provided as integral part of a single listed assembly incorporating both the protective device and power conversion equipment. Second, bypass circuit device, branch circuit, short circuit, and ground fault protection shall also be provided for a bypass circuit devices, where a single branch circuit, short circuit, and ground fault protective device is provided for circuits containing both power conversion equipment and a bypass circuit. The branch circuit protective device type and its rating or setting shall be in accordance with those determined for the power conversion equipment and for the bypass circuit devices equipment. So next we have 4.30.10.11 several motors or loads on one branch circuit including power conversion equipment. So, for installation meeting all the requirements of 4.30.4.3 that include one or more power converters, the branch circuit, short circuit, and the ground fault protective fuses or inverse time circuit breakers shall be of a type and rating or setting permitted for use with the power conversion equipment using the full load current rating of the connected motor load in accordance with 4.30.4.3 for the purpose of 4.3.4.3 and 4.30.10.11. Power conversion equipment shall be considered to be a motor controller. Next is 4.30.11 over 1000 volts nominal. 4.30.11.1 General. Part 4.3.11 recognizes the additional hazard due to the use of higher voltages. It adds to or amends the other provisions of this article. So 4.30.11.2 Marking on controllers. In addition to the marking required by 4.30.1 by 0.8, a controller shall be marked with the control voltage. So next is 4.30.11.3 Raceway connections to motors. Flexible metal conduit or liquid tight flexible metal conduit not exceeding 1,800 mm in length shall be permitted to be employed for raceway connections to a motor terminal enclosure. Next is 4.30.11.4 Size of conductors. Conductors supplying motor shall have an ampacity not less than the current at which the motor overload protective device is selected to trip. Next is 4.30.11.5 Motor circuit over current protection. General. Each motor circuit shall include coordinated protection to automatically interrupt overload and fault currents in the motor, the motor circuit conductors, and the motor control apparatus. Exception. Where a motor is critical to an operation and the motor should operate to failure of necessary to prevent a greater hazard to persons, the sensing device shall be permitted to be connected to a supervised annunciator or alarm instead of interrupting the motor circuit. Next is overload protection, B. So there are type of overload protection. First, type of overload device. Each motor shall be protected against dangerous heating due to motor overloads and failure to start by a thermal protector integral with the motor or external current sensing device or both. Protective device setting for each motor circuit shall be determined under engineering supervision. Second, wound rotor alternating current motors. The secondary circuits of wound rotor arc motors, including conductors, controllers, and resistors rated for the application, shall be considered as protected against overcurrent by the motor overload protection means. Third, operation. Operations of the overload interrupting device shall simultaneously disconnect all ungrounded conductors. Fourth, we have automatic reset. Overload sensing device shall not automatically reset after trip unless resetting of the overload sensing device does not cause automatic restarting of the motor, or there is no hazard to persons created by automatic restarting of the motor and its connected machinery. So C, fault current protection. First type of protection. Fault current protection shall be provided in each motor circuit as specified by either 1A or 1B. So A, a circuit breaker of suitable type and rating arranged so that it can be serviced without hazard. The circuit breaker shall simultaneously disconnect all ungrounded conductors. The circuit breaker shall be permitted to sense the fault current by means of integral or external sensing elements. B, fuses of suitable type and rating placed in each ungrounded conductor. Fuses shall be used with suitable disconnecting means, or D shall be of a type that can also serve as the disconnecting means. These shall be arranged so that they cannot be serviced while they are energized. 2. Reclosing. Fault current interrupting devices shall not automatically reclose the circuit. So, na po ni exemption. Isang exemption is automatic reclosing of a circuit shall be permitted where the circuit is exposed to transient faults and where such automatic reclosing does not create a hazard to persons. 3. Combination protection. Overload protection and fault current protection shall be permitted to be provided by the same device. Next, we have 4.30.11.6. Rating of motor control apparatus. The ultimate trip current of overcurrent or overload release or other motor protective device use shall not exceed 115% of the controller's continuous current rating. Where the motor branch circuit disconnecting means is separate from the controller, the disconnecting means current rating shall not be less than the ultimate trip setting of the overcurrent release in the circuit. Disconnecting means. The controller disconnecting means shall be lockable in accordance with 1.10.1.25. Next, we have 4.30.12. Protections of live parts. All voltages. So, 4.30.12.1 General. Part 4.30.12 specifies that live parts shall be protected in approved manner of the hazard involved. Next is 4.30.12.2 where required. Exposed live parts of motors and controllers operating at 50 volts or more between terminals shall be guarded against accidental contact by enclosure or by locations as follows. First, we have by installation in a room or enclosure that is accessible by only to qualified persons. So, second is by installation or on a suitable balcony, gallery, or platform, elevated and arranged so as to exclude unqualified persons. Third, we have by elevation to 1,500 mm or more above the floor. So, nagya po ni exemption. Isang exemption is, live parts of motors operating at more than 50 volts between terminals shall not require additional guarding for stationary motors that have commutators, collectors, and brush rigging located inside of motor and brackets and not conductively connected to supply circuits operating at more than 150 volts to ground. Next, we have 4.30.12.3 Guards for attendance. where live parts of motors or controllers operating at over 50 volts to ground are guarded against accidental contact only by location as specified in 4.30.12.2, and where adjustment or other attendance may be necessary during the operation of the apparatus, suitable insulating mats or platforms shall be provided so that the attendant cannot readily touch live parts unless standing on the mats or platforms. Next, we have the 4.30.13, the grounding all voltages. So 4.30.13.1 in general, ang part ko nung sa kayong grounding, specify the grounding of exposed non-current carrying metal parts like to become energized of motor and controller frames to prevent a voltage above ground in the event of accidental contact between energized parts and frames. Insulation, isolation, or guarding are suitable alternatives to grounding of motors under certain conditions. 4.30.13.2 Stationary motors. The frames of stationary motors shall be grounded under any of the following conditions. First, we have were supplied by metal enclosed wiring. Second, were in a wet location and not isolated or guarded. Third, we have if in hazardous or classified location. Fourth, we have if the motor operates with any terminal at over 150 volts to ground. Where the frame of the motor is not grounded, it shall be permanently and effectively insulated from the ground. So next, we have 4.30.13.3 Portable motors. The frames of portable motors that operate over 150 volts to ground shall be guarded or grounded. So, nagyan po na exemption. First, we have listed motor-operated tools. Listed motor-operated appliances and listed motor-operated equipment shall not be required to be grounded where protected by a system of double insulation or its equivalent. Double insulated equipment shall be distinctively marked. Second exemption. Listed motor-operated tools, listed motor-operated appliances, and listed motor-operated equipment connected by a cord and attachment flag other than those required to be grounded in accordance with 2.50.6.5. Next, we have 4.30.13.4 Controllers. Controller enclosures shall be connected to the equipment grounding conductor regardless of voltage. Controller enclosure shall have means of attachment of an equipment grounding conductor termination in accordance with 2.50.1.8. Nagyan may exemption. Enclosure attached to ungrounded portable equipment shall not be required to be grounded. Next, we have 4.30.13.5 Method of grounding. Connection to the equipment grounding conductor shall be done in the manner specified in Part 2.50.6. So, you have grounding through terminal housing. Where the wiring to motors is metal enclosed cable or in metal raceway, junction boxes to house motor terminals shall be provided, and the armor of the cable or the metal raceways shall be connected to them in the manner specified in 2.50.5.7a and 2.50.5.8. Next is separation of junction box from motor. The junction box required by 4.30.13.5a shall be permitted to be separated from the motor by not more than 1,800 mm, provided the leads to the motor are stranded conductors within types ECT cable, interlock metal type MC cable were listed and identified in accordance with 2.50.6.9.10a, or armored cord or are stranded leads enclosed in liquid tight flexible metal conduit, flexible metal conduit, intermediate metal conduit, rigid metal conduit, or electrical metallic tubing not smaller than metric designator 12. The armor or raceway being connected both to the motor and to the box. Liquid tight flexible non-metallic conduit and rigid non-metallic conduit shall be permitted to enclose the leads to the motor, provided the leads are stranded and the required equipment grounding conductor is connected to both the motor and to the box. Where stranded leads are used, protective as specified above, each strand within the conductor shall be not larger than 5.5 mm squared and shall comply with other requirements of this code for conductors to be used in raceways. C. Grounding of controller-mounted devices. Instrument, transformers, secundaries, and exposed non-current carrying metal or other conductive parts or cases of instrument, transformer, meters, instruments, and relays shall be grounded as specified in 2.50.9.1 through 2.50.9.9. Next, we have here the table 4.30.14.1 full load current in amperes, direct current motors. So, the following values of full load currents are for motors running at base speed. So, nata sa table ni armature voltage rating. So, nata tadi makita to is horsepower, 90 volts, 115 volts, 180 volts, 230 volts, 500 volts, and 550 volts. So, corresponding value sa horsepower, corresponding na murag armature voltage rating sa murag sa kayong sa 90, 115, 180, corresponding number na yung mga given value kara horsepower. So makita man sa atong na sa table na example sa horsepower 1/4 horsepower, sa 90 volts na 4.0, sa 115 volts na 3.1, sa 180 volts 2.0, to sa 230 volts 1.6, sa 500 volts wala, hasta sa 550 volts and so on. Sa horsepower sa 1/3, 1/2, 3/4 na. So next is we have the table 4.30.14.2 full load current in amperes, single phase alternating current motors. So, the following values of full load currents are for motors running at usual speeds and motors with normal torque characteristics. The voltage listed are rated motor voltages. The current listed shall be permitted for system voltage ranges of 110 to 120 and 220 to 240 volts. So, makita itong table rin mo itong para sa itong baba pero kanin full currents in ampere single phase ang trading current ni. So, na ito yung example, horsepower. 16 horsepower. Sa 115 volts, na 4.4, 7 volts, 2.5, 208, 2.4, 230, 2.2. So, sa so on. So, makita mo ito ng value sa mga horsepower na. So, next is table 4.30.14.3 full load current, two-phase alternating current motors or 4-wire. So, the following values of full load current are for motors running at speeds usual for belted motors and motors with normal torque characteristics. Current in the common conductor of a two-phase 3-wire system will be 1.41 times the value given. The voltages listed are rated motor voltages. The current listed shall be permitted for system voltage ranges of 110 to 120, 220 to 40, 440 to 480, and 550 to 600 volts. So, makita daw sa table rin na itong presing niya po sa itong mga last na kuan. Horsepower na 1/2, 3/4, sa value sa horsepower. Then, sa induction type, square cage and 1 rotors amperes. So, yung 115 volts, 230 volts, 460 volts, 555 volts, and 2,030 volts. Example, kanyang 1/2 horsepower. Sa 115 volts na 4.0, 230 volts 2.0, 460 volts 1.0, 560 volts 10.8, sa 2,030 volts wala. And so on na siya. So next is table 4.30.14.4 full load current, three-phase alternating current motors. The following values of full load current are typical for motors running at speed usual for belted motors and motors with normal torque characteristics. The voltages listed are rated motor voltages. The current listed shall be permitted for system voltage ranges of 110 to 20 to 40, 440 to 480, and 550 to 600 volts. So kani makita naman ta ni ang natag klase ani this induction type carrier cage and one rotor ug synchronous type unity power factor. Ana diri madukat tulo ka ang row ay column horsepower katong induction na siguro for example sa horsepower 1/2. So may tada dito 115 volts, 4.4, 200 volts 2.5, 208 volts 2.4, 230 volts 2.2, 400 volts 1.3, 460 volts 1.1, 575 volts 0.9. And then sa kuan sa 200 volts wala. Sa isang synchronous type unity power factor wala sa 230, 460, 575 o 2100 volts. And so na siya horsepower na mga corresponding value sa every volts. Then next is table 4.30.14.5a. Conversion table of single phase lock rotor currents for selection of disconnecting mains and controllers as determined from horsepower and voltage rating. So for use only with 4.30.9.10, 4.40.1.2, 4.40.5.1, and 4.55.1.8 C. So makita to diri sa atong table na diri na rated horsepower, maximum lock rotor current in amperes, single phase, 115 volts, 208 volts, 230 volts. So next na column, rated horsepower, maximum lock rotor current in amperes, single phase. So example ay punta, rated horsepower 1/2. So sa 115 volts, 958.8, 208 volts, 32.5, sa 230 volts, 929.4. Next is katong rated horsepower sa 3, ngayon sa maximum lock amperes, sa 115 volts, 104, 8 volts, 113, 230 volts, 102. Sa 5 rated horsepower, sa 115 volts, 136, 100 volts, 186, 230 volts, 168. Then sa rated horsepower sa 7 and 1/2, sa 115 volts, 480, 208 volts, 665, 230 volts, 240. Then sa rated horsepower, 10 horsepower, sa 115 volts, 1,000, 208 volts, 332, 230 volts, 300. And that will be all for my reporting, and other table will be discussed with my co-presenter. Thank you for listening, and God bless everyone.